Welcome. In this video, we will discuss how to create a vertical step in the top chord of a feature pattern truss to accommodate a recessed shower pan. Open up the Creation panel and navigate to the predefined truss shapes. Select the feature pattern truss. Here we will set the length to 21 feet and define both the left and right conditions as single ribbon. Click Next to review the structural details. We will stick with the default webbing settings since we'll need to adjust the webbing after defining the drop top chord section. Click Insert. For this example, the start of the shower pan drop will be 7 feet from the left end of the truss. The drop dimension will be 1.5 inches. Let's begin by removing all of the webs because we are going to add verticals at the start and end of the drop top chord section. Hold the Control key, which opens the multi-select filter. Set the selection filter to Members. Use your mouse to click and drag a selection box across all of the interior webs. It is also possible to open up the right panel to verify the selected members, then press Delete. Next, we will add a vertical web member at 7 feet from the left end of the truss. Right-click, Add Member, using the leftmost reference click, and drag the mouse while holding down the Shift key. This will change the increments of movement to feet. Once you're at 7 feet, click to place. With the web selected, change from centered on line to left of line within the Member Properties panel. Repeat this for the right web. Create Member, hold down Shift, and click to place the member at 12 feet. With W2 selected, change that to right of line. For this example, we're going to stack these vertical webs, which will create 3 separate zones for the truss. So select W1, right-click, then Stack Web. Notice when stacking the web, the placement was adjusted, such that the center of the stacked set is at the predefined location, which is at 7 feet. In this particular case, we want to change that back to 7 feet. So select the dimension and change that from 7 foot 1.5 to 7 feet. Press Escape. Next, we'll stack W3, select W3, right-click, Stack Web. Once again, the stacked set will shift, change the dimension to 12 feet, and enter. Next, we'll stack a segment of the top chord. This will serve as the 1.5-inch vertical drop. Select T2, right-click, Stack Chord. Here we will stack just a segment of that. In the Member Stack Insertion panel, we will modify the start location to be at 6 feet, and the end location will be at 13 feet. Click Insert. Next, we'll need to trim back the top chord members to accommodate the vertical drop. Select T3. Then, while holding down the Shift key, select the left side W3. Repeat that for T1, select T1. Hold down the Shift key and click the right side of W2. There you have it. Next, we'll verify the drop dimensions using Dimension Mode. So select Dimension Mode, selecting the lower left end of the truss, then select the top corner of T1. There we are at 7 feet. And repeat that for the right side, select the lower left end of the truss, then the top left end corner of T3. And that's at 12 feet. So that gives us our 5-foot shower pan void, or drop. Now we're going to define the webbing for all 3 zones. Because we added the stacked vertical webs, the feature pattern truss will automatically be recognized with 3 separate zones. So we'll start by auto-webbing the left zone. Click to edit Truss, Reweb Truss. Zone 1 is selected as the default zone because it is the leftmost zone, keeping the default settings for the webbing and for the chase. Next, click to generate the new webs. You'll notice that only Zone 1 was webbed. Next, we'll reweb Zone 2. So we'll edit Truss, Reweb, select Zone 2. We'll leave the webbing settings as is. However, the chase settings will need to be adjusted to accommodate a shower drain, which will be on the left side of the shower, so we'll make that fixed. We will leave the width variable. The fixed location will be at 8 feet, putting it at the left side of the shower. We need to leave plenty of room for that plumbing drop. So let's set the minimum width to 1.6 foot and the max width to 2 feet. Let's generate new webs. Next, we need to define the webbing for the right side or Zone 3. Edit Truss, Reweb Truss, Zone 3. Leave webbing settings as default. We could change this to no chase, but because it's unclear where the ductwork will be running, we'll go ahead and leave the location set to floating. Change the minimum width and maximum width to both be 200, and then generate. There we have it. Now that we've defined our webbing, let's see how this truss performs. Click Analyze or Control A. Members denoted in red are over capacity. By hovering above the top chord member, we can see this is 106% of the capacity. And then looking at the bottom chord members, we are at 122% capacity. The first thing we'll do is address the bottom chord members that are over capacity. Because the bottom chord is already spliced into two members, we don't want to stack the individual members, so we can select B2. Press the Delete key, which will automatically extend the bottom chord all the way across. Select B1, right-click, and click to Stack Chord. We're going to stack the entire bottom chord and insert. Next, we'll analyze and see how the truss performs. We did receive a notification about a plating error. An error occurred while plating the joint at B2 and W8. We can see there is a splice right there at this joint. We need to move the splice. To do so, select the splice. Click the gear icon to define the increments to move the splice each time you press an arrow. Make sure to change that to 1 foot. Close that and click on the right arrow to move that splice 1 foot to the right. Press Escape to exit and deselect the splice. Let's analyze. Again, you can press Ctrl A as the keyboard shortcut for Analyze, which is a great shortcut. Let's go ahead and reset the view. All checks pass, no notifications. This truss is ready for review. That wraps up this instructional demo for how to define a top chord vertical step and leverage rewebbing by zone to accommodate specific plumbing requirements. We hope this gives you a better understanding of the many tools available when designing feature pattern trusses. See you in the next one.